So, geometric sequence, series of numbers, bunch of numbers with a common ratio. Now what we're going to do is, just like with arithmetic, we can actually find the sum of all these things. So again, there's the formula. Guess what? You have to memorize it. No, it's on the sheet. You still know how to use it. You should recognize some of these terms already. T1, R, N, number of terms. What's SN then? The sum of whatever you're looking for, right? The sum, S10 is the sum of the first 10 terms. S100 is the sum of the first 100 terms. Does that make sense? Easy. Let's do an example right away. Okay, so we have a geometric sequence. Let's write down what we know. What's T1? What is R? 6 divided by 3, 12 divided by 6, 24 divided by 12. 2. Well, that's tough, eh? And we want to find the first 10 terms. So we're trying to find N is 10. So what are we looking for? That's a 10, right? We're trying to find that's a 10. Okay, write down the formula. What is the formula? Sn equals T1 R to, please note that's an exponent N minus 1 over R minus 1. Okay, now, before we even put the numbers in there, I'm going to tell you the most common mistake that you're going to make. And will some of you make it?
Yeah.
Yes, you will. Please note that is R to the power N minus 1. Where is that minus 1? Is it with the N or is it with this whole power? The whole thing. Where do you think the most common mistake is? They put that minus 1 with the exponents. Yeah? Yeah, trust me. They'll write it like R to the N minus 1 up the top. That is the most common mistake. I'm warning you now because some of you will make it. Then we'll all have a good laugh. Ha ha ha. Okay, let's plug in the numbers. So S of 10 equals what's T1? 3. What's R? 2 to the 10 minus 1, you see? Over top of 2 minus 1. Well, that's bottom's easy, right? What's 2 minus 1? 1, okay. So it's over 1. So basically we can just do the math on the top. All right, 2 to the power 10. 2 to the exponent 10. 2, 1024 minus 1. Right here, let me write out the numbers here just so we have it for the example. 1024 minus 1. 1024 minus 1 is 1023 times 3 is 10023 times 3 is 3069. Is that right? 3069. That one's easy. All right, example number 2. It's interesting, after the first lesson, right, that first 1.1 with introduction of arithmetic sequences, has everything just kind of been the same, really? Yeah, it's just variations on it, right? But you still kind of come back to it. It's the same thing over and over again, which is kind of nice in some ways in math because it makes it easier to learn. Okay, so what we have here is example number 2. Determine the sum of the first 10 terms of a geometric series with T1 equals 5, R equals a half. Ooh, I haven't seen one of these yet, have we? What's weird about this one? The fraction in the R, eh? Some of you will be tempted to do what with that fraction? Oh my goodness, that is such low-level thinking, guys. Don't always do that. Don't always change it to a decimal. You have to get used to working with fractions. That's not why we have a calculator. The best calculator to have is the one between your ears. Okay, so this is actually nice. They've labeled T1 for us already, R, and what's this? That's N, right? So this guy here is N. Okay, so write down the formula. N equals T1 R to the N, careful, minus 1 is the lower part, all over R minus 1. Okay, let's go what we know. Now, do not change it to a decimal. We'll leave it as a fraction. So we're finding S of 10, right? S of 10. T1 is 5. R is 1/2 to which power? 10 minus 1 over top of 1/2 minus 1. So how many look at that and they're like, I don't like that. Right? Yeah. What don't you? What? Be honest about it. What don't you like about it? The fraction in both of them, or just the one in the top or the one in the bottom? I mean, come on, think about the bottom one. Can you handle the bottom one? What's a 1/2 minus 1? Negative 1/2, right? Oh, that's not bad. It's the one in there that's that 1/2 to the 10. No, put that down. Put your calculator down. You've already done a bulk of this work in the previous question, didn't you? Think about 1/2 to the 10. Where does this 10 go? Does it go with both or just with the 1 or the 2? What does it go with? It goes with both. It's a 1/2 times 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 that. How many times? So guys, think about this. What's 1 to the power 10? 1. Now, 2 to the power 10, didn't we just do that? Didn't we just do 2 to the power 10? What is it? 1024. Okay, so what is that actual fraction right there then? 1 over 1024. Oh, well, that's not bad. Well, you see how you can actually do some of this stuff? Okay. So, writing it down, let's do the, the work. S10 equals 5 times 1 over 1024 minus 1 over top of negative 1/2. Okay. Now, it's a fraction on the bottom. Right? What do we do to that fraction? What is that? What does it mean to divide by a fraction? It means you multiply by what, though? A reciprocal. Remember that? Do you understand the word reciprocal for? Well, I don't know if it's the same in French or in English. Oh, that's what I'm asking. Okay. So what is a reciprocal, guys? No. You do not change the sign at all. All you do is take the numerator and the denominator and flip them. Okay. So if we have negative 1/2, the reciprocal of that is negative 2 over 1. That's the reciprocal, right? That's the term reciprocal term. Is that the same as in French as in English? Or? Okay. So when you divide by a fraction, it's the same as multiplying by the reciprocal. Isn't that correct? Okay. So instead of dividing by 1/2, we're going to multiply the whole thing by minus 2. Okay. So what you're doing is what's 5 times excuse me. What is 5 times negative 2? What is it? Negative 10. Okay, so the easiest way here, let's put I'll put a little note here so we can see this. This is the one that's kind of tough, right? So multiply by the reciprocal. Reciprocal. Okay, so we're going to times by negative 2 is basically what we're doing, right? Times by negative 2. So what does it become? S to the 10 becomes, what's 5 times negative 2? 5 times negative 2? Negative 10 times. Okay, now, let's do the inside stuff. Now, you should remember from grade 9. Here, let me put this here, sorry. 1024. You're subtracting 1. What's 1? But what is it? Is it 5 over 5? Is it 10 over 10? It's a whole, yeah, but could it be anything over itself? Is that right? Okay. The thing about fractions is we always need a common denominator. So what do we change that 1 to? 1024 over? No. 1024 over 1024. Isn't that right? Now look. Tell me if this is correct. 1024 over 1024. All of those numbers, is 1024 over 1024, is that 1? So that's exactly the same as what's written right there, right? Okay. Now, But why did I do that? We now have a common denominator, right? Does it make it easy to actually subtract them? Yeah, way easier. You see how you can do this without changing it to a decimal? The rules are still there. You just have to actually pay attention to them. It can depend on the calculator. Some of the calculators, like these sharp ones, will change it from decimals to fractions. That one definitely will, because you can actually, with the TI-83, you can press in math, you can go to fraction, you can go to decimal. But you should still know how to do this fraction-wise. Okay, let's do the math here. S10 equals you realize I haven't touched the calculator yet for this, eh? This question you can actually pretty much do entirely without a calculator, which is kind of cool. Negative 10 over. Now, guys, do this. What is 1 minus 1024? Positive or negative? Negative. Negative 1023 over 1024. Is that correct? Now let's do the math. What's a negative times a negative? A positive. Now guys, come on. You should be able to take 1023 and times it by 10. What are you adding to the end of it? A 0. Okay. So S10 equals 10230 over 1024. It's a big old number. Now, can you reduce it? Without a calculator, and you can do this with most calculators, right? Most calculators, you punch it down. If you've ever used the ABC button on your calculator, you actually punch in 100230 ABC 10024 hit equals. It will reduce it if it can. Have you ever done that before? Try it. Do this. So 1023 ABC. Where's your ABC button? Press that and press 1024 and hit equals. That is a mixed fraction, 9 and 507 over 512. Your is that a Staples one? Oh, no, it's a calculator. Where's your ABC button? Oh, my goodness. Yeah, usually. No, it's just a different calculator.
Oh, well, doesn't the button go?
No, some of them change. It might be that one. I'll look at it in a minute. Now, guys, if you didn't have a calculator to do this, there are rules of math that allow you to reduce stuff. What does this end in? What's that end in? What number will they both be divisible by? 2. Right? We know that, right? That's the basic rules of math. Cut that top one in half. Well, 10,000 is easy to cut in half, right? That's 5,000. 230, cut it in half. 115, right? So what is that? 5,115, is that right? Over top, I cut 1024 in half. And 512. I don't know if you recognize these numbers, by the way. 512, 1024, that's all the basis of computers, right? When you buy a 1 gigabyte hard drive, it's actually 1,024 megs. That's how computers work. They're all base 8, by the way. Yes. No. I was just giving an example. No. If you wanted more computer stuff like technology, computer, it's applied. That's applied math. Okay. So there's your, oh my goodness, there's your reduced fraction. Now, could you have done that as a decimal? Yeah, you would have got, what would you have gotten, right? 5115 divided by 512. Oh, good grief, 9.990234375. Whoa, that's really accurate. That's accurate. Right? That is accurate. All right, last example. Okay. So what we want here, we want to determine the sum of this sequence. Now, do we know the first number? Do we know the last number? Could we figure out R? Yes, we could. What's the only thing we're missing? What? N. How many terms are there? I don't know. Those dots in the middle mean it just goes, we're missing something in the middle. So we're missing N. Well, it's kind of hard to do when we're missing N. How do we find N then? How do we find n? Right. You got to go back one step. You have to go back to the series sequence of a series. Right? Remember that formula from yesterday? This is a typical question. You have to go backwards to get n, so then you can go forwards to get the sum. Yeah? You're going to see a lot of these. This is a common way to ask this. Okay, so first thing we got to do is we got to find n. It's lost. It's like Where's Waldo, right? We got to find n. You guys like the Where's Waldo books? Remember those? I still read those every day. Okay, what's the formula for previous day? T n equals, what is it? T1 R n minus 1 at the top. Okay, so that's our basic formula. Okay, now let's put in what we know. Let's write out here. We know, what's T1? 4. What is the nth term? What is the nth term? What is the last term? Careful. Negative. Okay. Here's the tough one. What's R? Wrong. It's what a pirate does. R. That's a bad joke. What are you doing? Negative 16 divided by positive 4. Negative 4. Positive 64 divided by negative 16. Negative 4. So that's how you double check, right? Do it twice, right? So R in this case is negative 4. It's interesting, these numbers, look, positive, negative, positive, negative, positive, negative. You can have a sequence that alternates back and forth. Right? Because it's R, it's a multiplication, right? Okay, so let's plug in what we know. So Tn is negative 65536 equals 4 R to the, what is R? Oops, sorry. 4 times negative 4 to the n minus 1. Why did I put negative 4 in brackets? It's negative, and if I put 4 minus, it would look like 4 minus 4, wouldn't it? But it's really 4 times negative 4, right? I often use brackets just to keep things clear. Now that's ugly. That is ugly. What do we do with this one? Divide by what? Divide both sides by 4. Would I get rid of the one in the front? Yeah, so divide both sides by 4. Bang, bang. Okay. Negative 1, 6, 3. I'm trying to do this in my head. What is it? A4, thank you. Equals negative 4 n minus 1. Okay. Now, you had one of these questions yesterday, didn't you? Kind of at the, I think it was number 7 or something you got to it. And you're like, the problem with solving for this is you really haven't learned in the past how to solve for an exponent when you're trying to solve for something up the top there. But you know the basic rules of math when it comes to bases and powers, right? The bases. Remember back in grade 9 you learned if two things have the same base, the exponent laws, right? The exponent laws. If they have the same base and you're multiplying, you add the exponents. If they're the same base and you're dividing, you subtract the exponents. Do you remember that? They have to have the same base. It has to be key. So you're looking at this one and you're going, well, first off, the base on this one is, on the right is negative 4. The base on this one is sure not negative 4, isn't it? Okay. But if we could make them the same basis, could we do something with the exponents? Yeah. Now, when you do these examples in this math class, and I give you one of these, they will always work. I'm not going to give you one that doesn't work. So somehow we have to take this guy, right here, this negative 16,384, and turn it into a base of what? Negative 4. Okay, so basically what I want is I want a base there, and I want this base over here. And what I'm looking for is I'm looking for something right here. I want to know what number I could put up there that would turn that negative 16,384 into a base of 4. So how do you do this? Well, is it going to be a 2? What's negative 4 squared. Positive 60. No dice. What about 3? Negative 4 times negative 4 times negative 4, negative 64. Not happening. I don't know if you notice those numbers, by the way, that I'm just talking about there. Are they the same in the sequence, by the way? Other than the sign, but... 5? 6? How do you do it? Honestly, what do you do sometimes in math when you don't know how to do something? You do what's called? Estimate, trial and error. What is it? Is it 7? Okay. So, basically what you're doing is, you can do that. You'll learn in grade 12 how to do it a little bit more mathematically. But you're saying, is it a 7? And double check. Now here, guys, easy way to check. That exponent, even or odd? Odd. So when we do it with a negative, our answer is going to come out negative. Do you remember those rules? If that sucker was even, the answer would come out positive. Do you remember those? We did that with negative 1, I think. Okay. Does that work? Is 7 the right one? Okay. So are the bases the same? Okay. So really all we worry about then is, how do we make this guy equal to this guy? And look, isn't that really just a formula? Isn't it 7 equals n minus 1? What the heck is n? It has to be 8, right? 8 minus 1. Oh, okay. So n equals 8. Cool. The ones you get in this class, will they always work like this? Yeah, I'm not going to give you one that's like stupid. Yeah, because they're all going to be smaller ones, right? You learn in grade 12, you learn because what happens, do you remember logs? Did you take logs already? Log x with a, no, okay, you'll take it in 12. In this case, we're not getting into that because it's not of importance until you actually get into logs. This one is just basically looking at it visually, right? Yeah. Okay, now, we found out what, yeah.
So, like, it sounds like the negative 6 or 1, 6, 2, 8, 4, that's always going to have, like, you'll always be able to turn that into the same base.
The ones I will give you in this class, you always will. If you can't, guess what? You've done something wrong. Right? We don't go through the really, really difficult stuff. That's when you hit grade 12 and we start getting into logs. Right? And what logs are is the word log with a base and an exponent. And you actually have to do all these rules, and there's some really complex rules that go with them. But you'll find that. In this case, it's just a basic level. It's just you're looking at it and you should be able to figure it out. Okay, where are we? Oh, we're still trying to find the sum. Oh, my goodness. No, do we know what n is now? N is 8. Okay, so now let's find the sum. Let's find the sum. So what's the formula for the sum? See how easy that would be to write n minus 1? Every time I write it, I always have to be careful that I don't write it n, r to the n minus 1 up the top. Got to be super careful of that. Oh, yeah, let's go on what we know. S of, what are we looking for? S of what? How many? 8, thank you. T1 is 4, thank you. R, negative 4, what's the power? 8 minus 1. All over top of negative 4 minus 1, is that right? Now think about this for a minute. Before we even do the work, think about this for a minute. Positive, negative, sorry, Jason. Positive, negative, positive, negative, positive, negative. We're adding them together. Are you going to get a really big number, or are you going to get a smaller number? You don't know, right? But look at what the last term was. What was the last term? Right. So it might be less than that, right? Because if you add positive and negative, some of them are going to cancel out as we go along, right? Just don't be surprised when you see your answer, right? Let's do the math here. Okay, so S8 equals 4. Negative 4, it's to the power 8, so we know our answer is going to be positive, right? Because it's an even exponent, right? Negative 4 to the power 8 is 65, 536, is that right? 65, 536, minus 1. All over top of, what's negative 4 minus 1? Negative 5. S8 equals 465,535, all over top of negative 5. S8, just do the math. 4 times that divided by negative 5, what is it? 52,428 negative? Is that right? Double check my math. Remember, I'm a math teacher. I script all the time. You got the same? Did you get that? Yeah? You guys get that? Yeah. Sorry. Tell me to get out of the way when I'm standing in front of the board. Literally not that hard. Again, it's just variations on the formula, isn't it? You use that same formula and you do it different ways. You solve for n's, you solve. This is a common thing, though, to go backwards and then to go forwards. Go backwards, then go forwards. Okay? Get the questions? Get it better.